Welcome. Today we're going to be taking a look at Java development, some of the basics we have to do so we can actually talk about how to do Java development here in class and doing it overall of how we're working with it. Some of the vocab that we need to go over so we can actually talk about Java development are listed right here in this slide. So we've got the JRE, the Java Runtime Environment. You'll see this when we're working inside Eclipse. It's what we add to our class path so we can know what we're working with. This is how Java knows how to actually run the code we're talking about. The JVM is the Java Virtual Machine. This is where our code actually executes. It's a nice little piece of space inside our computer's operating system. It's a little carved out virtual space that we use to actually operate where the code itself operates and where that executes inside there. So we have that happening. Java, of course, is the language we're working with. This is how we actually, the code we write, we're using the Java language to make that happen. Of course, its previous code name was Oak, in case you need that for some quiz on some tests or something like that. When we compile our Java code, we get bytecode. So after we compile the code from our Java files, it goes into bytecode that we keep inside our .class files, and that's the stuff we actually is executed inside the JVM is where that happens. I'm using the IDE of Eclipse. IDE is the integrated development environment. That's where we actually write all our code and it executes our code. It's a great tool for doing lots of cool work with that. There's other IDEs out there. You can work with them. On the one you'll see in all my videos and what we work with is Eclipse. There's a whole bunch of other. They're all great. Well, possibly the exception of Dr. Java. We compile our code, and that's when we take the actual code and we run through the Java compiler, Java C on the command line. And what that does is it takes the Java code that we write as human beings, it parses that information out, it sends it to the Java compiler, and it says, oh, take this Java code and build the bytecode from it. And that's where we take from the human written stuff to the actual bytecode, and that's generated when we actually compile that code. We execute the compiled code, and that's execute is how we actually run it. We're not killing anything, not really anything like that, but that's how we go through on that. We have Java keywords, also called reserved words. These are the things that belong to Java. They're special words. We see them all the time, like public and class, static, void, not main though, however. We also see some things like new. These are words that belong to Java, and we can't use them on our own. We have to use them the way that Java tells us to, and we'll talk a look at how we go through that as we go through and do our development process. The class is the blueprint for the object. That's the biggest thing we're making all the time in Java. We're making classes. That's how we make objects. And so that's one of the biggest things we'll be doing all the time. A body or block of code is the chunk of code denoted by squiggles. It's the chunk that we're working with. So you have the class block, we have a method block, we have if blocks, we have for loop blocks, we have closure blocks, but basically a block of code is anything denoted within a set of squiggles from top squiggle to bottom squiggle. And it allows us to actually go through and deal with a unit of code and how we'll work with that. Data members are the variables that belong to a class. I use data members, the term. You might also see it as fields, properties, instance variables. There's a whole bunch of things that you can also call that. I like data members. It's the term that I prefer to use, but there's a whole bunch of variables, and those are the variables that belong to the class itself. And by design, they're always private. And we'll talk more about that as we go along. We also have local variables. Local variables are when we do use that in anything that's not at the class level scope. So these are the ones that would exist inside a constructor, inside a method, inside a for loop, inside an if block, something like that. They're variables that exist only for that scope of that smaller block of code. And these are variables that don't have a value assigned by default. So keep that in mind. We'll talk again about that some more too. Methods are how we make actions in Java. So anything we want to make code do something, an action we want to perform, that's a method. You might also sometimes see these referred to as either procedures or functions, and the method is what we use to actually make an object do something. We'll talk a lot about that as we go through the year, but that's just a quick vocab on that. Parameters are how we send information to the method or to a constructor. It's a way of sending information in there, and we'll use those all the time to actually go through and do stuff. The return type is what comes back from a method. That can be anything from void, int, string, char, or anything you create inside Java. But what is coming back from that. And so the return type is what comes back from a method. And it's always the what we see after we have public and then void main. So public is the visibility, void is the return type, and main is its name. And then I also will refer to the word stub a lot. Stub is that just a quick little piece of code that I use to make sure we have some bare functionality, just it'll compile and it'll not break, because I like to have things so that at the very least we have a stable piece of code, and so we use stubs all the time to make that happen. And so that's what we were going for with that. The next thing we have is we want to talk about is our naming convention. I'm really big on naming conventions. It's something I'm really quite passionate about when we're talking about this. Names are for humans to read. We want to make sure that when we're writing our names for our code, that we ourselves as humans can actually read it really well. I have the idea that this should be a very boring name, but very descriptive name, so it describes exactly what's going on. We use Pascal case. We have capital letters starting and capital letters for each additional word, and we're talking about projects, classes, and constructors. Classes and constructors, of course, have to have the exact same name as well. Camel case, with the lowercase than capitals for every other word on that, is how we do with variables and methods. And we do this because of the fact that computers are not very good about spaces. They just get like all wiggy and squishy about that. And so we can't use that with it. So instead we use Pascal case or camel case to handle it so we humans can read it more easily. For packages, we use a naming convention where it's all lowercase with separation of periods to have that happen. And we'll see examples of that throughout the code as we go throughout the year. We'll see that all the time. Now, I have a personal minimum requirement of at least 3 letters for all variables. That means no I, J, L, R, X, K, Y, C, whatever. And that's because of mostly because of handwriting. When you're writing the code by hand, especially, say, for example, for an AP test or for a classroom test, I can't tell if you're handwriting if you mean an I or J half the time, and I don't want to actually fight with this. So that's why I and J and L are out automatically. R and C, if you have bad handwriting, R and C's look a lot alike. So again, those two are right there. And then X and Y don't often mean what you mean them to be, think when you're talking about them in code. And so I want you to actually make sure you specify exactly what they're talking about. Specificity is better than short. And so, again, we go to that second bullet on there, boring but descriptive. We know exactly what we're talking about when we're using those naming conventions. We also have some style conventions here in class. I'm very big on the vertically aligned squiggles. I like to see it like that. So if I look over your computer upside down like that as I'm walking around the classroom, I can easily see that your code is in the right scope. I don't have to focus in the details. I can immediately see that vertical line right there, upside down even, and see that your code is where it belongs to. Project names don't get spaces. It's because we're putting them directly into GitHub and we can't handle spaces with that. So again, no spaces on project names. I also really like the one statement per line. I like to keep it really clean so that we're doing this line of code, then this line of code, then this line of code. We don't need to do a giant series of steps on that. It's like just do one thing at a time. We're not worried about line count like that. It's easier to read things one at a time and make sure it keeps track in our brain as well as the instructions that we send to the computer. Methods should do only one thing and one thing well. So it's like, oh, if it takes 5 lines to do that, great. If it takes 10 lines to do that, great. If it takes 500 lines, we probably need to squish that down and break it apart. And so one of the rules of thumb on that is like, oh, you want to name it for what it is, what it does. And then if it starts getting too big, you're going to break that method apart into pieces. And it's like, oh, here's this chunk and then this chunk, and I'll call them from another part. That way I'm breaking it down so I have the parts of things I'm doing. And so I can decompose that as I go along. We'll talk about refactoring and decomposing a lot more as we go through this, but that's just the basic idea as we go through that. We have some class conventions as well. So I like to have my classes fairly organized. Again, I'm kind of picky about this. So we have the classes organized in the following order. We have our package statement at the top of the file. We have the imports that belong to that. We have our class header. And then inside the class, we have the data member, the constructors, and then methods. And methods should be organized by functionality. So when we're talking about getters and setters, the getters are all together, the setters are all together. And as you write your other methods, well, the methods that work together will be placed also together. Makes a lot of sense, makes it real easy to work with and find and review your code as you go through that. And so we'll talk about using that as we go through and do larger projects, talking about how to put them together to make sure it makes the most sense for you, the human, as well as for the computer, because it doesn't care about Java. We have a project style we're working with here in class as well. I use an MVC approach, or model view controller. That's the architecture we do for all of our projects. And it's designed to try and make it so it's easy to reflect what's going on in the real world inside our projects and code, and make it so the piles of code we work with are small and easy to maintain and also transferable. So the model package is where the things that we make that are going to be doing the real world stuff. It's the stuff we're making for our project. If I was doing a project about airplanes, this is where the airplane.java files would live, because it's like, oh, these are the models we're representing inside the project. Anything that we're making to do stuff in the project lives inside the model package. The view package is where we put stuff that relates to the GUI side of stuff. If I want to make a display screen or a window or something like that, that code all lives inside the view package. And we'll see that as we go through the year, starting about November or so for this class. The controller is where we start most of all, and that's where we have the runners and the controllers that start our class. The runner is the same thing all the time. It just has the public static void main in it. And the controller starts off the same with a constructor and a start method. And that's where we actually build it up, start it off and going in, and we'll send messages from there to tell the other parts of the program what to do. And we'll go through that in a lot more detail as we go through our code. Check out some of the other videos on how to use MVC structure to do that as well. We also have some Javadoc conventions. We want to make sure that our code has some proper documentation as we go through. I want to start this off with a year as we go through very early on that we're having Javadoc to build our code as we go through this. And so Javadoc belongs in all of the following. It belongs in the class headers, the constructors, data members, especially early on to help you learn what those pieces are and know what's going on with it, and especially for final projects so you can document this as a professional would. And then most methods should also get that Javadoc documentation. The only ones that I don't require it at all are the main method, because it's only going to do is start the project, and the getters and setters. There are one-liners that do exactly one thing, and the name of it, get or set, tells you exactly what it's doing, so we don't need additional documentation for that. But our other methods should have documentation explaining what's happening, especially when it comes to parameters and return values. We'll go over that again as we go deeper on the projects and see how that works. Finally, we're working with Eclipse. We have our package explorer holds our projects on the left-hand side. We have our editor window. We work with our code. Our console error and warning messages window has what we see on the screen. We're working in console land. We have our green play button that we can use to run our programs, and the red box on the right-hand of the window for errors. We can see exactly what's happening inside our Eclipse editor, so we can see, oh, here's where those errors live. That's just a quick little overview for that. And finally, some quick tricks we can use inside Eclipse. Save one file is Command S, save everything is Command Shift S. This is a great one to use by default. Personally, I love this. Make your code pretty, Command Shift F it formats your code so we have all our squiggles in the right spot. If you need to rename something, you right click, you refactor and select rename. You can also quickly do that by doing Alt Command R. It's a little bit faster for that. Some window fixes in case you accidentally close a window. If you need to add a component, you go to the window drop-down menu and go to show view. Or if you need to close too many, you don't need where you're going, go to window and reset perspective. Will bring it back to what it's supposed to be for the Java default settings. I hope this is a quick helpful on how we can do some introductions to working with Java and doing Java programming. Have a great day. Cheers. See you next time. Bye-bye.